Here are some more examples of function evaluation. For the first one, given that g of x equals x divided by square root of 4 minus x squared, find g of 3. So where x is in the original, I will substitute in the 3. I'm using parentheses where the x's were originally, and this one it definitely is necessary because of the square that we have on the bottom. On the top, we can end up with just 3. On the bottom, 4 minus, and then 3 squared is 9. That will simplify as 3 over square root, and then when you subtract 4 minus 9, you get negative 5. Something about roots is that you cannot take square roots of negative numbers within the real number system. Definition of square root means 2 of the same value that multiply to the value under the root. There is no way that I can multiply 2 of the same values to get me a negative number. And so for this particular example, the answer that I got out would be not a real number. Later in the semester, we will learn that this is an imaginary type of value, but for right now, the correct notation for your answer needs to be g of 3 does not exist. Alright, the next part down, part B, we're asked to evaluate g of 3/4. Make this a little larger so we can see it. So g of 3/4 equals 3/4 over square root 4 minus 3/4 squared. I wanted to be sure to do an example that had a fraction in it so that we could talk about several ideas that may be rusty for you. We'll have 3/4 on the top. In the denominator, we'll have 4 minus, and then when you square a fraction, you should square both the numerator and the denominator of the fraction. So 3/4 squared should be 9 over 16. From here, it's a matter of what order do I need to do the problem in. First order of business would be the 4 minus 9/16 on the bottom. To be able to subtract fractions, you have to have a common denominator. So I would put 4 over 1, and then to get a denominator of 16, I would need to multiply the top and the bottom both by 16. Notice that this all happens underneath the root, and it's like you're ignoring the root for right now. Doing that, 16 times 4 is 64, 16 times 1 is 16, minus 9 over 16. Since I then have a common denominator, I can subtract the two fractions in the denominator. Keep the root sign. 64 minus 9 would be 55 over 16. From here, I would need to take the root. There's a rule that says you can take the root of a fraction by taking the root of its numerator and dividing by the root of its denominator. So essentially put the root symbol over both the top and the bottom. The reason I'm doing this is because I can take one of the roots while I can't take the other one. 3/4 stays on top. I can't take the root of 55. Also notice that if you were to factor 55, 55 is 5 times 11. So even factoring 55, there are no perfect square factors contained within it. And so we don't do anything with the root of 55. So here, root of 55 would stay in the top. Now, root of 16, I can do that. Root of 16 is 4. Okay, this particular problem is really all about reducing. Alright, we've got this big old division bar here in the middle, and I'm going to think about it actually as division. Recalling a rule from dividing fractions, to divide a fraction, you keep the top fraction, you change division to multiplication, and then you flip the bottom fraction. So keep it, change it, flip it. Keep 3/4, change division to multiplication, flip the bottom value. Okay, doing this, because I'm now multiplying fractions, I can cross reduce. Those will reduce to a 1. So seemingly, it looks like I'm getting 3 over square root of 55. Now, there is something that we call rationalizing the denominator. And to be able to get the answer right online, you must rationalize the denominator. To do this, you can multiply the top and bottom of your resulting fraction by whatever you have in the denominator. To rationalize the denominator means get rid of the root that you have on the bottom of your denominator. If you multiply by that exact same root, then by definition of roots, if you multiply the same root by the exact same root, and you're dealing with square roots, then you're getting only the number that's underneath. On the top, you can't multiply 3 and the root of 55, and so you'll just leave it as 3 roots of 55. Okay, so on this one, the answer would end up being that g of 3/4 equals 3 roots of 55 divided by 55. You may want to star this problem, it's rather involved, but I wanted to show you the fraction operations as well as how to rationalize the denominator at the end.